In this video series, we will explore work and gravitational potential energy. Specifically, we will examine the conditions required of vertical work. We'll look at the vertical work formula and its units. We will be introduced to the work energy theorem and the concept of gravitational potential energy. We will do an example of how to calculate gravitational potential energy, and we will explore the importance of path independence and some important examples. So let's first look at the conditions for vertical work. Throughout our examples today, we are going to feature a guest, and our guest is the pangolin. The pangolin is a highly endangered animal. It is the most heavily trafficked, illegally trafficked animal in the world, being used, eaten for meat in the Far East, as well as for pseudo-scientific medicinal remedies. Its scales. It's a pretty incredible creature. If you wanted to learn more, do a search of it in YouTube, and you could watch some amazing videos of it. So we will feature the pangolin in our examples. So our scenario we are looking at here is we have the ground, and we have a tree, and we have vertical height, which we could consider the z dimension. Vertical is z, or we could talk about it as being a change in height. So if we have this pangolin who is on the ground and we are in the process of lifting it upward, doing work vertically, we want to examine the forces. And the forces we have are the force of gravity downward and the applied force. Now, the condition that we must have, and this is important, is that the movement must be at constant velocity. And here's why. We know the net force is the sum of the forces, using Newton's second law. And the net force is ma, and our two forces involved are the applied and the force of gravity. Well, if it's at constant velocity, then the acceleration is 0. And if the acceleration is 0, ma is 0, which means the force applied and the force of gravity add up to 0. Therefore, the force applied is equal and opposite to the force of gravity. So we can label them this way. So we know what the force is that's being applied. That's what's critical. We want to know what the force is because we know that work is the average force times the displacement. So we need to know this force, and to know this force, the movement must be at constant velocity. So the condition is that the velocity of motion must be constant.